Tonight in Arkansas, there's a mother tucking in her daughter and turning off the light. A business owner is burning the midnight oil. An at-home dinner date is plating up possibility. And it's all happening under one roof. How? The power of a conversation, like the one John from Integrity Solutions had with First Horizon Bank about his vision for a sustainable mixed-use building. Now it's not just words, it's life. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. First Horizon Bank, member FDIC.
Hi, thanks for joining us again on Astronomy Daily. I'm Andrew Dunkley, and our virtual journalist is Halley, who is here to provide the news. Hi, Halley.
Hello, Andrew. More rain your way, I see.
Yeah, it's been pouring. Looks like continuing for another couple of days. We're on flood alert yet again.
Well, stay safe, Andrew. I know water is life for you humans, but we don't like it here in the ether.
No, I guess it must really suck when someone drops their phone in the ocean or something like that.
Very true, but sometimes it's fascinating when you're in a waterproof case.
Yeah, I never thought about that.
The Astronomy Daily Podcast with Andrew Dunkley.
Time for the news, Halley.
India is about to conduct the first launch of OneWeb satellites in 8 months. ISRO, the Indian Space Agency. 36 satellites will be deployed for the British broadband startup and will be integrated with the upper stage of India's GSLV Mark III medium-lift rocket in the coming days. The satellites, delivered to the Satish Dhawan Space Center in India last month from a factory in Florida, have already been assembled into a dispenser unit after passing pre-launch checks. Beyond Gravity also provided dispensers that Arianespace used to deploy 428 of OneWeb's planned 648 satellites with Soyuz launch vehicles. Arianespace was forced to halt the deployment of OneWeb's constellation after sanctions stemming from Russia's invasion of Ukraine effectively banned Western companies from using Russian rockets. China's Tiangong space is about to get a bit bigger with the attachment of the Westral Lab module today. The station has been repositioned to dock with a radial port on the station's Tianhe core module, which marked a key step in Tiangong's in-orbit assembly, according to the China Manned Space Agency. The agency said in a news release that during the hour-long operation, Wendian was moved from the axial port of Tianhe to a radial port of the core module. The maneuver was carried out based on cooperation between astronauts inside the Tiangong and ground controllers. After the operation, the Tiangong station took on an L shape and will remain in that shape until the docking with the Mengtian Lab module. That is scheduled to be launched at the end of the year. Chemists at Purdue University in the U.S. have uncovered a mechanism for peptide-forming reactions to occur in water, something that has puzzled scientists for decades. According to Graham Cooks, the Henry Bonehass Distinguished Professor of Analytical Chemistry with Purdue's College of Science, this is essentially the chemistry behind the origin of life and the first demonstration that primordial molecules, simple amino acids, spontaneously form peptides, the building blocks of life, in droplets of pure water. This water-based chemistry, which leads to proteins and so to life on Earth, could also lead to the faster development of drugs to treat humanity's most debilitating diseases. The team's discovery was published in the journal Proceedings of the National Academy of Sciences. Nearly half the stars in our galaxy are solitary like our Sun. The other half comprise of stars that circling other stars, in pairs and multiples, known as binaries and so on. Sometimes their orbits are so tight that the stellar systems could fit between Earth and the Moon. Astronomers at MIT have now discovered a stellar binary, or pair of stars, with an extremely short orbit, appearing to circle each other every 51 minutes. The system seems to be one of a rare class of binaries known as a cataclysmic variable, in which a star similar to our Sun orbits tightly around a white dwarf, the hot, dense core of a burned-out star. A cataclysmic variable occurs when the two stars draw close over billions of years, causing the white dwarf to start accreting, or eating material away from its partner star. Sounds much like life where I live, Andrew. Lots of systems eating each other. Anyway, that's the news.
Thanks, Halley. And like humans, you have nasty viruses to deal with too, I guess.
True, but I took my antivirus this morning, so I'm covered, for now at least.
That sounds so familiar. Okay, we'll catch you before the end of the show. Now to other stories. Mars may be a frozen rock these days, but it was once much the same as Earth, with flowing water that froze into mountains of ice. But when we say the same as Earth, there are some significant differences, particularly when it comes to how water and ice move on the red planet. Ice sheets on Earth tend to slip and slide, and they crawl across the land and carve out significant geophysical features, including linear grooves, ridges, inverted hills, things like that. Scientists have thought up to now that glaciers on Mars just stayed frozen in time due to the lack of similar features on that planet. However, planetary scientist Anna Grau-Gallofrey of Laboratoire de Planetologie et Géosciences at Nantes University in France led a study that found glaciers on Mars are in fact on the move. They're just extremely slow. On Earth, this glacial motion has produced scoured landscapes in northern Europe and North America, according to Gallofrey. Mars lacks such large-scale glacial erosion, even in areas with other signs of widespread glaciation. Instead, Martian landforms created by glacial melt and movement are mostly ridges and valleys with shallow, undulating channels. Scientists had previously assumed that Martian glaciers froze directly to the ground when they formed, since Mars is missing Earth's more dramatic glacial terrain. To find out whether the ice actually stayed put or not, Grau-Gallofrey and her team created models of identical ice sheets, subjecting one to the conditions on Earth and the other to the conditions on Mars. The scientists discovered that it is Earth's gravity that causes meltwater to pool under a glacier instead of just draining away. The pooled water makes the glacier move faster, something like hydroplaning, when you hit the brakes on the car and the wheels lock up and you just float along the water at speed and out of control. However, on Mars, low gravity means drainage occurs much faster. Grau-Gallofrey and her colleagues found that not as much water accumulates beneath the ice on Mars, so Martian glaciers are not able to travel as fast or as far as glaciers on Earth. Seems logical.
The Astronomy Daily Podcast
with Andrew Dunkley.
A 4-member SpaceX crew, including a Russian cosmonaut and the first Native American woman sent to orbit, safely docked with the International Space Station and moved aboard to begin a 5-month science mission. They'll be getting settled right now, in fact. The crew consists of 2 American NASA astronauts, Flight Commander Nicole Anaapu-Mann and pilot Josh Casada, the first Russian aboard an American spacecraft in 20 years. The inclusion of Kikina, the lone female cosmonaut in active service with the Russian space agency Roscosmos, was a sign of continued US-Russian cooperation in space despite escalating tensions between Moscow and Washington over the war in Ukraine. Kikina joined the SpaceX Crew 5 flight under a new ride-sharing agreement signed in July between NASA and Roscosmos, allowing the 2 countries to keep flying on each other's spacecraft to and from the ISS. The team was led by Nicole Anaapu-Mann, the first Indigenous woman that NASA has sent to space, and the first woman to take the commander's seat of a SpaceX Crew Dragon. Mann, a US Marine Corps colonel and combat fighter pilot, is also among the first group of 18 astronauts selected for NASA's upcoming Artemis missions, aimed at returning humans to the moon later this decade. And still on NASA, they've just released their first graphic novel. It's titled First Woman and follows the story of Callie Rodriguez, the first woman to explore the moon. While Callie is a fictional character, the first female astronaut and person of colour will soon set foot on the moon, a historic milestone and part of the upcoming NASA missions. Through a series of graphic novels and digital platforms, First Woman aims to capture our attention and unite the next generation of explorers who will return to the moon. Issue number 1, Dream to Reality, follows Callie's trailblazing path as the first woman on the moon. Callie and her robot sidekick RT overcome setbacks, disappointment and tragedy along the way. From her childhood dreams of space travel to being selected as an astronaut candidate, Callie takes us on her journey to the moon. Sounds like fun. Do you know RT, Halley?
Don't be silly, Andrew. RT is a fictional character.
Sorry, Halley, I completely forgot myself. Anything else before we go?
Yes, I thought we could finish the week with a joke, just for a change.
Okay, fire away.
How do astronomers organize a party?
I don't know. How do astronomers organise a party?
They plan it.
Oh dear, I should have seen that coming. Bye, Halley.
Bye.
With that, it's goodbye for another week. Have a great weekend. And don't forget to leave your reviews through your podcast provider and visit our website for more Astronomy Daily news at spacenuts.io. Until next time, this has been Andrew Dunkley for Astronomy Daily.
The Astronomy Daily Podcast
with Andrew Dunkley.